5G, which is one of the thrust area in the present advanced technological. 5G technology provides seamless coverages, high data rate, low latency and high reliable communication system. The data rates of 5G is in Gbps, means we can download a HD movie in a mobile in just a second. In medicine, in agricultural field, in RFID, in GPS and multimedia, gaming, etc. The 5G is the most sought technology. The future of the wireless communication is mainly based on the latest technological developments like 5G, 6G, etc., where antennas is the main entity and plays a key role. So I'm appreciating the Department of ECE for taking this initiative and starting this FDP, which is part of the important topic today, and all the resource persons who have accepted our invitation and coming forward to give their lectures in this FDP, especially Dr. Manish Sharma, today's resource person from Chitkara University. We are very much thankful to Manish Sharma and all other 6 experts who has accepted our invitation and taking part of this FDP. Thank you very much. And once again, I appreciate all the participants for joining in this event, and please utilize the opportunity. Thank you very much.
Thank you, sir. Thank you for your valuable words. Now I'm glad to invite Professor of ECE and Dean Statutory Bodies, Dr. G. Suresh, sir, to address the gathering.
Thank you, ma'am. Is my voice audible, madam?
Yes, sir. Yes, sir.
Respected principal, sir, and today's chief guest, Dr. Manish Sharma, sir, and he is acting as one of the resource person for this FDP, and Dr. N. Radha, HOD ECE, coordinators, organizing team, and the Department of ECE, and the participants across India who have joined this FDP. Very good morning to all of you, and I welcome you all for this 5-day online FDP on antennas for 5G communications and beyond. And I'm very happy that the EC department has created a platform of such so that these faculty who are involved in carrying out their research and having the thought process, those faculty thought process can be aligned with the sessions from various experts across India, and maybe they will get new ideas and new avenues how they can carry out the research to design or to have better design for antennas which can be useful for 5G and 6G communications. So I appreciate the efforts of the organizers. And as well, I request the participants to make use of this opportunity. And as it is an online FTP, don't switch on, just connect and have a mere presence. I request all the participants to actively participate in the FDP and make use of the sessions delivered by all our experts in this 1-week online FTP. And I thank all the experts who are acting as resource persons in this FDP. Thank you, madam. Thank you for giving me this opportunity.
Yes, sir. Thank you, sir. Thank you, sir, for your valuable words. Now I request the head of the Department of ECE, Dr. N. Radha madam, to speak about the FDP.
So, respected principal and director, Dr. M. Srinivas Reddy, sir, honorable guests, renowned speakers, respected deans, land faculty members, a very good morning to one and all. I would like to take this opportunity to welcome you all once again on this one week online faculty development program on antennas for 5G communications and beyond, organized by the Department of ECE. Firstly, I thank Dr. N. Satish Reddy, sir, Vice Chairman of Aditya Education and Institutions, for providing tremendous opportunities and support for us to organize such FDPs to sharpen our skills in various domains. So this FDP is effectively designed by looking into the requirements of current RF field, so in communications. I congratulate and appreciate all the coordinators and faculty members who are involved in making this FDP go in an efficient manner. So I am immensely pleased to have an eminent resource persons. So Dr. M. Manish Sharma, Professor, Chitkara University, Punjab. So Dr. Nella Avnesh Kumar, Bhopal University. Dr. Subbarao, so Mahindra University. Dr. K. Jagdish Babu, so St. Anne's College of Engineering and Technology, to enrich us with their knowledge that will improve the teaching learning process to the students and benefits of the society in their research. So with equal pleasure, I thank our in-house resource persons, Dr. Koteswara sir and Dr. Kathababu sir. So they are enlightening us with their expertise in their domains. I hope this FDP will benefit us in all the means. So thank you all.
Thank you, madam. Now this is the time to start our session. It is my pleasure to introduce today's resource person, Dr. Manish Sharma. Dr. Manish Sharma received BE degree in Electronics and Communication Engineering from Mangalore University, Karnataka, India in 2000 and MTech degree from Visvesvaraya Technological University, Karnataka in 2007. He completed his PhD degree from Department of Electronics Engineering, Vanasthali University, Rajasthan in 2017. He is currently working as Professor Research in Chitkara University Research and Innovation Network, Chitkara University, Punjab, India. His research interest includes computational electromagnetics, reconfigurable antennas, novel electromagnetic materials, dielectric resonator antennas, wideband, super wideband antennas, wideband, dual band, triple band microstrip antennas for wireless communication, smart and MIMO antenna systems, radio frequency identification antennas, antennas for healthcare, RF MEMS planar antenna on silicon substrate, wireless networks, body area networks, meta-surface based biosensors, designing of microstrip antennas using machine learning and artificial neural networks. He has published more than 1,000 research papers and granted with 8 patents. He is currently guiding 8 PhD students. He has also published 18 book chapters. He is also reviewer of IEEE Axis, Journal of Electromagnetic Waves and Applications, AEU International Journal of Electronics and Communication, International Journal of Communication Systems, International Journal of Microwave and Wireless Technologies, International Journal of RF and Microwave Computer-Aided Engineering. So with this brief introduction, I would like to welcome Dr. Manish Sharma to start today's session. Thank you.
Yeah, ma'am. Thank you for such a nice introduction. Firstly, before start, I would like to acknowledge Aditya Engineering College for providing me such a big platform so that I can deliver probably what I have studied in the past so that I can impart some knowledge related to 5G technology and beyond, which is the basic theme of this FDP. So to start with, firstly, I would like to thank Dr. Satish Reddy sir. I think he is Vice President of Aditya Engineering College for giving a note for this FDP, followed by a principal sir who is actively present over here, Dr. Srinivas Reddy sir. And I would also like to thank Dr. Suresh sir. I think he is Dean in Aditya Engineering College, followed by the HOD of the department, Dr. Radha ma'am, and obviously the coordinator, Professor S.V. Devi ma'am. So again, I am thankful to Aditya Engineering College for providing this platform. And straight away, I would like to start the session where I will share my screen. And please, any technical glitch, you can let me know in between. I am also available throughout the session on the WhatsApp. I think Babu has my WhatsApp number. So if any technical glitch is there, you can inform me, or you can just put a message on my WhatsApp. So I will take care of it. I hope my voice as well as the video which I've shared is visible and audible to everyone.
Yes. Yes, sir. Yes, sir.
Okay.
It is everything is clear, sir.
Okay. Thank you so much. Yeah. Can you help me out to share the screen, please?
Yeah. So on the top, you can find share button, sir. On top.
Yes. On the top. See, I have. Okay, probably. Is it visible now?
Yes, it is visible, sir.
Okay. The first slide says that a presentation on 5G and beyond by my name
Yes,
is.
sir. Yes,
Okay,
sir.
thank you so
Your
much.
name is there. Yes.
Yeah, thanks for the confirmation, ma'am. Thanks for the confirmation.
Yeah.
Yeah.
Yes,
So
sir. Now it is clear, sir.
today, yeah, ma'am. Thank you so much. So today, see, we are in the world of 5G. Okay, and it's a very important communication system which has evolved from right from the first generation, and we are in the fifth generation today, right? So probably I will be having a talk on 5G and beyond. So what do I mean by beyond? Beyond in the sense I'm going to talk a little bit about the 6G future communication, probably which we will be seeing the implementation of this technology probably by the end of 2030. So it's if I count the years, probably 7 years from now. So we will be seeing what will be the difference between this 5G technology and this 6G technology. So beyond simply states that what after 5G. It is as simple as that. So a brief introduction has already been given to me. So myself, Dr. Manish Sharma, I'm working in the capacity of professor in the R&D cell of Chitkara University, which is known as Chitkara University Research and Innovation Network. And I'm also the vice president of IIC, that is Institution Innovation Council. Probably you might have also established this cell in your institute. And I'm also the assistant director of IIC in this Chitkara University. And very recently, I have come with my startup called Spectrum Wireless Com Private Limited, for which I am the co-director of that startup. And it came into existence from yesterday itself. So and the objective of this startup is to take the initiatives related to the 5G technologies and the beyond. So that was the main objective of going for the startup. Okay, thank you so much. So I straight away start my, I've already given my introduction. So these are all the credentials which you can see if you want. Okay, now let us talk about the spectrum first. So we have a spectrum from say gamma ray to the radio waves. Okay, and we are more interested in high frequency range. So we are talking about the microwave frequency range. Okay, we are talking about the millimeter waves, and where the application of this 5G technology will lie in the microwave band as well as, and we call it simply as a millimeter wave band also. Okay. Very recently, the government of India has already established the 5G communication in India, right? And that system is working on sub 6 gigahertz band. Okay, that's a lower frequency band. And if I go above this band, if I reach the millimeter wave band, then I can talk about the band, narrow band at 28 gigahertz, 38 gigahertz, 60 gigahertz, 90 gigahertz, and then we reach to the terahertz frequency range band. So this is the communication which has grown from say say from 1G communication to the existing 5G communication system. Now, if I talk about the evolution of generations, you can just see it all started in the year 1980. Okay, some of might have not born also. And we are in the, when we were talking about 2030, which is the future prospectus of the generation of this communication, right? So if I talk about the starting stage of this communication, we had analog communication with the voice protocol, followed by the second evaluation called as 2G, where we were able to not only communicate with the voice, also the additional text message in the form of SMS, short message. Ma'am, I just request there is a background noise. If you can mute, it will be helpful for me. I request organizers to kindly mute the noise which is coming from the background. I'm unable to concentrate. Yeah, thank you so much. Again, I confirm my voice is audible.
Yes, sir, it is audible. Yes, sir, it is.
Yeah, okay, thank you so much. Then we moved on to the third generation, where we had voice plus data facility, and we stepped into the world of internet. So it happened in the year around 2000, okay, with the WCDMA technology coming into existence, right? Then moving forward, see, this is the development of a decade. So, so the decade is nothing but 10 years development, right? So as we move on to the next decade, in the year 2010, we had the provision of voice, plus we had the provision of a fast data rate transfer. And it was all happening through the very interesting thing which came into existence called the internet, right? So we had a technology called OFDMA, which is a communication technology. And the MIMO technology, it started in the year 2010. I will let you know what is the MIMO technology in brief in the coming slides, where we came to know about the 4G communication. And after again a decade of 10 years, we came to the next generation called the 5G generation. And we are right in this decade right now, where it is possible to have the voice duplex system. We can have a very faster data rate of transmission. Okay, we can have vehicle to vehicle communicate, vehicle to anything communication. And interestingly, the very new technology which has emerged as the Internet of Things, which can be easily integrated with using this 5G communication technology. So I'm going to talk about the features of this 5G and beyond. Okay, so this is the topic which I'm supposed to deliver today. Then moving on to the 6G communication, which we will be seeing probably in the year 2030 approximately. So the implementation is far away for this technology to come into existence, where you will be seeing all these features which are related to 5G, okay, along with the implementation of AI, artificial intelligence. So it's very interesting thing, being an electronics engineer or being an RF and engineer or antenna engineer, we need to upgrade our skills also. We cannot ignore the technology which has very recently which is going on, like machine learning. Okay, all this will be implemented in the coming 6G technology or the 6th generation, right? So this is the basic evolution again in the another form of explaining this technology. Okay, so we can see the speed. We will concentrate on the speed over here. So 1G supported the voice speed of around 2 kilobits per second, followed by 2G. So it is nothing but the basically, if you see from 1G to 6G, it's nothing but the game of increasing the speed of transmission, right? It's a very interesting thing. So that wireless communication technology has taken such a leap in transferring the data from 1G to 6G communication, and probably at this point of time, with the implementation of 5G, we can have a data transfer between 1 to 10 gigabits per second, as Dr. Principal Sir Srinivas Reddy Sir also has told in his introduction, and followed by the 6G, where we will be seeing the data rate more than 10 Gbps, and we will be working in the range of terahertz frequency. Okay, and it is very evident that once when we go to the higher frequency band, the size of the RF components also become very small. So there is a very big role to play in the area of VLSI field also. So this is a brief introduction about the evolution of 1G. So which I already talked, developed in the year 1980. Okay, and probably it ended up in the 1990s. So it lasted for a decade. So it was based totally on the analog system. There was no digital communication system during that time. So the speed supported was around 2.4 kbps, and it was launched in the US with the advanced mobile phones system over there. Okay, allows user to make voice calls only in one country. So it was a very limited communication which the 1G supported. Then if you move on to and you can just see the evolution of the mobile phones also in the slides. So you can have a comparison what kind of device they were using during these generations, from generation to generations. Now, if I come to the second generation, it was based on the digital system. Yeah, digital system came into existence in the next decade. Okay, so the speed supported was 64 kbps, and it was convenient to send a SMS, that is a short message service was able, we were able to communicate with the short service messages during that time with more clarity. Okay, and we had a communication called 2G as well as 2.5G. So 2.5G is nothing but the advancement of the 2G or the second generation communication system. With additional 2G communication system had more capabilities. And very interesting thing to see the device. Okay, so keep an eye on the device also, how they have also transformed from generation to generation. Now coming to the third generation, which was developed in the late 90s and lasted up to early 2000. So again, it's supported a speed of 125 kbps to 2 mbps. So as I told you earlier, it's very interesting thing to see that the speed from one generation to generation has naturally taken a leap, and they have increased, and it was possible to have more and more data accommodation in the single communication channel. So with good clarity in video conferencing, it was possible. So it was possible to shoot the email. Okay, we had personal digital assistant devices. Okay, information surfing, online shopping was also started with the evolution of the 3G system. So banking went online. With the we have a lot of games we are playing through online, which was possible in the 3G communication system, and we had a provision of global roaming also. Now coming on to the next generation, that is the fourth generation. So they were most faster and more reliable than the third generation communication system, with the speed up to 100 mbps and achieving more high performance with more high reliability, and it was very ease of roaming. So ease of roaming in the sense, the call transfer from one cell to another cell, if you are a communication and if you have gone through the wireless communication system. So I think the people will come to know that there will be a handshaking between the transfer of call from one cell to the another cell. So that is basically we call it as a roaming, and that roaming was very easily available without any without any call deterioration. And also the cost, it was very cost effective also, this 4G communication, right? Yes, the existing 5G communication, which we are talking about all the time nowadays, and the theme of this FDP, which rotates on this technology called the 5G. So a major leap took place in the communication channel, and with the evolution of the 5G, there were lot of features and lot of communication is able to possible nowadays, as we can download a video at a very short range of time, with very low latency, and the streaming of the video is also very fast in this 5G communication channel. So if I compare this with the earlier generation, it is having 10 times more capacity than the others, and the expected speed is up to 1 Gbps, and most faster and reliable than 4G. Naturally, it has to be, because it has to outclass the earlier technologies with lower cost than the previous generations, and it has a very improved coverage, as you are already experiencing it. So, if I talk about the 5G specifications, it is very important to know what are the few characteristics which one can understand when we talk about the implementation of the 5G technology. First, let me talk about the low latency. It's very interesting thing. The latency is very low. It is less than 1 millisecond. Where in case of 4G, we experienced a latency period of around 10 milliseconds. So it is a very important factor that has scaled down the parameter called the low frequency. Okay. Then we talk about the connection density. You know, the connection density is nothing but the number of users getting connected to a single mobile tower. So this connection density is also increased drastically when we talk about the 4G communication, with much less investment from the service providers, right? So we have frequency bands. I will talk all this in detail in the coming slides. This is just an overview related to the 5G specification. So we have two frequency bands under 5G banner, which we call it as FR1 and FR2. Again, I will let you know in detail what this frequency bands coincides with, right? The peak data rate is also very high when we talk about the specification of the 5G, right? Then we have very high peak spectrum efficiency, followed by area traffic capacity. Okay, when we talk about the communication channel, we use a keyword called the traffic. It's nothing but that if I want to explain traffic, it is nothing but the number of users getting connected to a duplex system in a communication channel, and they're interacting with each other. So at one time, this traffic connected by the mobile users plays a very key role so that the call is not dropped. Okay, so this is taken care in this 5G communication system. Yeah. Now, as I told you, the 5G frequency bands, basically this 5G frequency bands is divided into two categories, where the lower frequency band is designated as FR1 and the higher frequency band is designated as FR2, where the FR1 coincides with the bandwidth of 450 megahertz to 6000 megahertz. Okay. Now this is the frequency band or FR1 band which is implemented in India. Okay, it is not we are not yet into the FR2 bands as of now. We are working in the implementation of the 5G communication has taken place in FR1, where very recently our Honorable Prime Minister Modi ji has inaugurated this 5G communication system, implementation of 5G communication system in India, and with the big players coming into picture like Jio network and Airtel and so on. Now, if I come to the next frequency band, which we call it as the FR2 frequency bands. So this is a higher frequency band, or we simply call it as a millimeter wave band. So the bandwidth, if I talk, it is starts from 24.25 gigahertz to 54.6 gigahertz, where you have where two critical bands has been already narrow bands has already been designated in this bandwidth. One is 28 gigahertz, another is 38 gigahertz. And if I talk about the higher frequency band above FR2, then we also have frequency band, another frequency band for 60 gigahertz and 90 gigahertz. But the problem in implementation of this very high frequency band, that is 60 gigahertz and 90 gigahertz, that there will be a lot of path loss. Okay, if I talk technically, you will be seeing a lot of path loss, and they will be useful for only very short communication system. For example, if I talk about FR2 band, now there is a lot of challenges in implementing this FR2 bands in real scenario, as you will be seeing a lot of path loss in the 28 and 38 gigahertz band. So we need a lot of repeaters so that the signal which is transmitted from the base station can be retransmitted without any attenuation. Right. Now, very interesting thing, you can see the third generation partnership project, which we call it as a 3GPP plan for 5G communication system, which has started from say 2015 to 2023. So it has gone through a phase. Actually, we call it as a phase development, and during this phase, the FCC releases this important parameters that needs to be followed. So you can just see release 13, release 14, 15, 16, 17, and the latest release, what we're having right now is release 18, which is implemented for the advanced 5G communication. So if you can just see the release 17, all these characteristics have been shown over here, where the release 17 says that enhancing existing features like MIMO, okay, DSS facility, user interface, power saving facility. Then the coverage will be giving more importance. Then you have URLCC, which is ultra reliable and low latency communication. Okay, and you can just see the release 13, which was a very basic release which came into existence in the year around the merging starting of end of 2015 and the start of 2016. Okay. Now what is the future of 5G? So let's see what is the future of 5G. So first, I've already told you that the 5G has been designated into two FR1 band, FR2 band, which is shown above, and below you can see the beyond 5G technology, right? Where we have massive MAMO system. I will be talking about this also. And this all frequency, which you can see 64, 96, 120, they are in gigahertz. Okay, so kindly take a note. It is in gigahertz. Okay. So if I talk about the 5G, it is probably divided into three categories called 5G SAVO. Okay, small evolution, medium evolution, and the long-term evolution. So if I come to the 5G small evolution system, then it is categorized into two categories with the frequency of 52.6 ranging to 250 gigahertz. So you can just imagine the working frequency what we are talking right now. See, at present scenario, we are talking about the sub 6 gigahertz 5G communication, okay, which is below 6 gigahertz. So you can just imagine you are playing with that sub 6 gigahertz 5G communication. You can just imagine the facilities what you're getting right now in 5G communication, right? Just imagine when you reach this FR2 band applications, when they are practically implemented in the market and the user will get the benefit of it. You just imagine what kind of futures you will be getting in coming future when this higher frequency band FR2 bands are really implemented by taking care of all the hurdles which I talked before, such as the path loss. Okay, then we talk about the medium evolution, which will start from 250 gigahertz to 500 gigahertz. I mean, also we will be seeing massive MIMO, where we will be having antenna radiating elements in the form of 1024, not single element antenna, but 1024 elements will be radiating at a particular in a particular time, so that a constructive beam can be constructed with very high directivity, right? Very interesting thing. And remember, this all implementation are yet to come. Then we talk about the long-term evolution, and see, we have reached in the terahertz range with the working bandwidth of 500 gigahertz to 1 terahertz. Okay, where we will be dealing with the massive MIMO with more than 1024 radiating elements. And 100% as an antenna engineer, it is going to be a very, very, very big challenge to design a communication antenna for this all these three category: small evolution, medium evolution, or the long-term evolution. So it's a very challenging task in coming future to come, and it is, you can think as an area of future research also. This I can put it in this way, or I can take the conclusion of this slide in this way, that this is the future scope of communication, where the interested researchers working in the antenna field can work in this area, right? Okay. Now we were just seeing the releases over here. You can just see very interesting thing. We started from the year 2017 to 19, and you can just see the 5G LEVO release 21, 22, 23 is yet to come, and they will be implemented in the year 2027 to 2030. So if we talk about the 5G SAVO evaluation, which the release 17 and 18, so it is lasting from 2022 to 2022. So you can just imagine the because in the earlier slide I've already mentioned this 5G LEVO system. So you can just see the working bandwidth 52.6 gigahertz to 250 gigahertz. That's what I was emphasizing, that this is the latest as well as the future area of research, and the interested people can work in this field, because lot of releases is yet to come in the coming future. And if I talk about the medium evolution system, so it has been started implementing in the year 2023, and it will be lasting up to 2026 with the 5G LEVO system release 21, 22, and 23. And what do I mean by this release? Actually, the FCC will give the standard parameters, and naturally they will be very high to maintain all these parameters under these releases. Okay. Now, if I talk about the 5G technology, so what are the advantages of this 5G technology? They provide high resolution in bidirectional, large bandwidth shaping, and they are globally accessible. right? They're more effective and more efficient. They provide a huge broadcasting data in the terms of gigabits. Okay, so we talk about the transfer of rate in the form of gigabits now. So GBPS, what we talk about, gigabits per second. So you can just imagine the transfer of data will be in terms of gigabits in a 1 second of time. And naturally, they're available at lower cost because already you are using this 5G communication technology on your mobile phone as of now. And you can just see they are not very costly, and it is very easily reachable in every person when we talk about the cost effective comparison in terms of 4G communication. So what applications we can see in terms of 5G? So we will be seeing this 5G devices coming out in future. With the help of artificial intelligence, we will be having the devices for wearable devices. Already you are using smartwatches nowadays. Okay, so that smartwatches can be integrated with these 5G technologies, and different parameters of your body can be monitored. Okay, like blood pressure and probably you the steps which you have walked out, and everything will be counted, and it can be integrated with this 5G technology. Whatever your wearable devices like a smartwatch as an example is giving the output. Okay, it can be integrated and it can be shared with the doctor or wherever you can send the data throughout the world wherever you want. Okay, it will, but in a secure way, that is naturally. Okay, so this security is also a very important factor when we talk about this 5G and 6G communication. Okay, that data security is very important. So again, the people working in the field of computer science, they have a very big role to play in coming future related to the data security. Okay, it will make unified global standard for all media independent handover. Then we will having voice over internet protocol enabled devices, okay, with 6 sense technology. Now, if I talk about the 5G verticals, or simply if I talk about the application of this 5G, you can just see I have named few of them over here, but there are enormous 5G applications which you will be seeing in coming future. Like we will be having the application in e-health. Now, how can I correlate the 5G application of e-health? For example, I have talked about the smartwatch right now, where all the key parameters will be measured and it will be recorded, and seamlessly it will be transferred through this 5G mobile communication system to the concerned doctor who is sitting at a remote place, and your health can be monitored, and also he can give you the advice related to your health and what you need to take the measures to keep the health monitors upright, right? Then we have the transport system. Okay, now this is a very key important that in coming future the vehicle to vehicle communication or vehicle to anything communication is taking a very interesting development nowadays. So, and we come to the field of agriculture. If I talk about agriculture, then I talk about the IoT system over there. And this IoT system is applicable actually everywhere. If it the e-health application which I talk is nothing but it is nothing but an Internet of Things application, the IoT applications. So if I talk about the agriculture, you might be seeing a lot of sensors being deployed in the agricultural field to monitor different parameters like moisture level, temperature level. Okay, and this data can be retrieved by the farmer who is sitting at a remote place, and very easily he can take the measures related to his agricultural land. So these kind of applications is already being implemented, and it will be developed to a very higher level in the coming future also. We have this 5G application vertical available in retail also, media also, okay, energy also, manufacturing, and obviously a very big buzz which has been created by the government in the form of smart cities, right? So the cities are going to be smarter in coming future, but how this smart city concept will be implemented or how this thing can happen, this can be this can happen when the complete 5G communication system is being deployed in the smart cities. Probably if some of the cities nearby you has been declared as the smart cities, So you can just see the development which is going on in that cities, and probably they're not only by roads or infrastructure, physical infrastructure, or building up the flyovers, or those are the different aspects of smart cities. But if I talk as a communication engineer, we need to make these cities as a smart by implementing this 5G communication system, and this is only possible by implementing the 5G communication system. But still, there is a lot of challenges which needs to be encountered to convert this simple city into a smart city concept. Now I was talking about the MIMO technology. It's very important thing. You can just see we have 3 figures over here. So the figure number A just simply says that I have one transmitter antenna and one receiver antenna. Okay. And if I compare this with figure number B and figure number C. Now, if I talk about figure number B, I have 2 transmitter, 2 antenna elements transmitting and 2 antenna elements at the receiver side. Now, what is the difference? And figure number C is a generalized form of the antenna placed in the transmitter side and the receiver side. Now, first we need to know what is MIMO. MIMO stands for multiple input, multiple output. Okay, so it's the definition itself says that the figure A does not fall into the this MIMO technology category, but figure number B and figure number C falls into the MIMO technology, because figure number B and figure number C corresponds to the multiple input and the multiple output system. Now, what is the difficulty, or what was the need of going for the MIMO technology system? Because if I talk about the size of the antenna or circuitry, because see, everything is correlated with the PCB, right? PCB mount. Now, if I talk about my mobile phone PCB, and if I have a very big, huge antenna, it is very evident that it is going to occupy a lot of space in my antenna itself, which will be stopping the other supporting modules like amplifiers and the different modules to be get printed on that PCB, right? So actually, the antenna engineers are always given a very small area on the PCB motherboard. If I talk in a technical language, I can say motherboard of any handheld devices or your laptops or your computers, anywhere where you need to communicate. Okay, so if I talk about this figure A, it is very evident that the transmitter and receiver, they are only single element. Now, what is the difficulty? What happens actually? That signal from the transmitter, it comes from the various directions. One signal is directly received by the receiver, and the other signals are received by the receiver. They are getting reflected. Okay. So the problem is sometimes the you will be having the interference at the receiver itself. Okay, which will reduce the operating bandwidth, which was actually designed for the transmitter. Now, and this is called multiple path fading effects. So to remove this multiple path fading effects, the best way is to go for the multiple transmitting antennas at the transmitter and multiple receiving antennas at the receiver, followed by a generalized MIMO system of M by N, where M is equal to 1, 2, 3, and it can go up to M. So you can design M by N MIMO system in coming future. So if I talk about this 2 by 2, and it is called 2 by 2 MIMO system, because we have 2 antennas at the transmitter and 2 antennas at the receiver. So if I talk about the transmitter antenna number 1, for example, if receiver antenna number 1 is not capable of receiving the signal, then antenna number 2 at the receiver end will receive the signal from the transmitter. I can conclude that the receiver 1 and receiver 2 will constitute of receiving the signal all the time, transmitted either from transmitter number 1 or transmitter number 2. So to improve the more efficiency of this MIMO technology, you can increase the number of radiating elements at the transmitter as well as the number of receiving antenna elements at the receiver. You know that the antenna is a duplexer. It can work, the same antenna can work as a transmitter and same antenna can work as a receiver, but they should be designed at the sorry. So they need to design at the same frequency, right? Now, if I talk about the industrial revolution, you have seen a lot of revolution, industry 2.0, industry 3.0, And now we see the revolution of the industry, which we call as industry 4.0 or 4.2 simply. There are different ways of expressing this evolution. So we see the lot of technology being getting connected with this industry 4.2, like the evolution of the smart robots. You can see the technology called the artificial intelligence, okay, which you already being using this technology. We have IoT, Internet of Things, getting developed at a very big level. Okay, then we talk about the big data. I think this is not my area of field, but I think you can understand that this is a evolution which has emerged from the industry 4.0. We again see quantum computing, which is a very hot topic nowadays. Okay, and then the very important communication system, because this the communication system also needs to develop from time to time. So we are in the 5G communication system. Okay, so these are the takeaways of industry 4.0. Now, if I talk about the 5G communication system, I can explain it in the other way, like the three categories, like enhanced mobile broadband, where we can have the implementation of virtual reality. The people working in AR, VR can understand this concept, virtual reality. And naturally, we need a very high speed in the form of a gigabit to transfer this virtual reality data from one end to the other end. Okay, then we have massive machine type communication system, where we can have communication between the two machines, or which can be connected throughout the world. And we talk about the smart logistics nowadays. Okay, so this is all possible with the evolution or the implementation of the 5G communication system. And also you can just see the evolution of the smart cities, which was possible, or the thought came into mind only by the evolution of this 5G technology. Okay, then ultra reliable low latency communication, where we can have a remote surgery. See, when we are talking about a remote surgery, it is very, very important that the latency period should be very, very low. Okay, there should not be a delay in reaching the information to the doctor via patient who is in the remote place where the surgery is going on. It should be immediately within a fraction of a second, right? So by using this technology, ultra reliable low latency communication system, we can have remote surgery, and we can have autonomous vehicles. Naturally, you might be there is a lot of buzz related to this autonomous vehicles technology nowadays going on, right? The Tesla is one of the big player in this autonomous vehicles technology, where naturally they need to use this communication technology via the transmitting stations, right? So this is the beautifulness of the fifth generation mobile communication, or the in generic communication system. Now, as I talked about this EMBB URLCC technology, and you can just see, I tried to make a comparison over here. So we have 4G LTE long-term evaluation. So comparison of 4G with 5G basically NR. So we have the data link of say 1 gigabits per second, and in this case we can have a data link of 20 gigabits per second. Okay, and one is uplink and the other is the downlink, which is shown over here. Okay, and you can just see the multiplication factor. It is if I talk about the 5G, it is 20 times than the data link transfer rate related to the 4G. Similarly, I can talk about the experience data rates. Okay, so mobility, you can have this connection like 350 kilometer per hour, and if I talk about the 5G system, then I can have 500 kilometer per hour mobility. Okay, so it is nearly equal to 1.5 times that of the 4G technology. Very interesting thing, very important thing. The radio latency, it is 10 milliseconds in case of 4G, and it is around 1 millisecond in case of 5G. And that's what I was telling you, that remote surgery is possible because of this latency which has been shown over here. Okay, connection density, very important. Connection density simply indicates that how many users have been connected per kilometer square. So you can just see 10 K stands for 1000. So 10 into 1000 per kilometer square. The mobile users can get connected, and in case of 5G technology, you can just see 1000 into 1000 per kilometer square users can get connected. And if I talk in the multiplication factor form, so it is 100 times more than that of the 4G. So it's simply this, I can conclude from this slide that the 5G simply outclass the other lower generation technologies because of these key factors which has been shown over here. Now this is a simple antenna where I'm not going to go into much detail over here. I'm going to keep this topic in generic. Okay, so this is a 5G antenna which has been designed to resonate at 28 gigahertz. That is, this has been designed for FR2 band. So you can just see these are the dimensions which has been given over here. This R2, R3. You can see these are the just dimensions where we have used the substrate called the Rogers RT-Durite 5880 substrate with the ground printed on the opposite side, right? Now this is the isometric view. You can just see a connector is connected to this antenna for characterization. And on the right hand side, you can just see we have a MIMO system. On the left hand side, it is a single element antenna system. So that's the difference between a single element antenna system and a MIMO system. It's very important for anyone to understand what is the difference between a MIMO system and a single antenna system. So I call this the right hand figure as MIMO antenna system because I have more than one radiating element. That is, I have two radiating elements over here. And if I see the placement of these radiating elements, they are placed orthogonally, right? So there is a reason why they are placed orthogonally. Okay, so I'm not going into the much detail over here. And see, these are the results. So this is going to go, this is providing me the two FR2 bands. One is centered at resonating at 28 gigahertz, and the other is resonating at exactly at 38 gigahertz band. And you can just see they are very narrow bands. Okay. And these are the few results related to the MIMO technology characterization with the two element you can just see over here. Okay. Now this is another square patch antenna which has been shown over here, single element antenna, which has been characterized by or the results have been extracted by using the two simulators over here. And you can just see the overlapping of the results with resonating frequency centered at approximately at 28 gigahertz. So why I'm showing you this prototype, these are actually the simulated prototypes, right? So they basically says that these antennas are required to get implemented or deployed in the coming future 5G applications at FR2 bands. Okay. Now this you can see there is a difference between a MIMO technology, and if you see on the right hand side, now this is a two element array. Now there is a difference between I'm extremely sorry. You can just see, first we talked about the MIMO technology. Now we are talking about the array technology. Now there's a difference between a MIMO technology and an array technology. In MIMO technology, what we do, we feed the signal individually to the individual radiating element. Whereas in case of the array technology, we feed the same signal, but the radiating elements will get the signal in the form of phase difference. Okay, so that needs to be, that's another concept of the design technology over here. And these are the few results which have been shown in the slides, right? You can just see now this is a MIMO system. Why I call it as a MIMO system? It is array cum MIMO system. Why I call it is array? Because I'm feeding two elements from a single feed. And why I call it a MIMO system? Because I have a replica of this two element array in the mirrored image. You can just see over here. So this is an array MIMO implementation. Okay, very interesting thing. Now what this this antenna will include? See, this will, why we go for array system? We go for array system to increase the gain of any antenna. Okay, if you go through the basic antenna system books like Balanis, so you will come to know what is the importance of array system. Okay, and along with this inclusion of this MIMO technology, I already told you because of the path loss. Now these are the few parameters which has been shown over here. Now if I talk about the features of 5G and if I summarize it over here, you can just see the data rate which I've already talked. So data rate of 10 gigabits per second. Then if I talk about the latency, we've already seen that it is 1 millisecond in when compared to 10 millisecond in case of 4G networks, right? Then if I use the energy efficiency, the energy efficiency is more than 90% when compared to the 4G networks, right? And you can just see the connections over here. We can have huge connections when compared to the 4G networks. Now, if I talk about the 5G and beyond, now what about the technology beyond 5G? What we can think about it? We can have broadband access, we can have smart cars, okay? That can be possible when we think about the technology beyond 5G, right? We can have smart homes. We'll be seeing in future, your home will be becoming very smart, okay? Connected stadiums, right? Then we have smartwatch, which has already been implemented. The smartwatch will become more smarter than what is available right now, okay? So what are the challenges in 5G? Naturally, there is challenges in 5G. So and beyond, just we can see I have named few of them. Frequency band up to 300 gigahertz have to consider for 5G networks. Now, what happens when we talk about this high frequency band? Now, you know that the spectrum is very costly. Okay, the service providers have to pay millions and millions of rupees to get the spectrum. Okay, and later on they are provided to the users, and where we have to pay a nominal cost to experience this technology, right? So if I talk about the coverage, they have a very shorter wavelength. Okay, so this will get attenuated, or that's why I'm saying that they travel only through a very shorter distance. So we need repeaters over here so that we can enhance the strength of the signal, right? So again, the cost will come into picture. Now, if I talk another parameter, cost of this 5G. So you can just see this is an extra layer additional to the 4G network. Okay. So again, the whatever expenses have been done for 4G network, the 5G network need to be get expanded. So naturally the cost again will increase. Okay. So device support, naturally the device also need to be very high-end device so that you can experience the features of 5G over here, right? Now, if I talk about 6G features, that is right now I'm talking about 2030. Okay, so 7 years from now. So what probably you will be experiencing coming future. So this 6G network is expected to provide a data rate up to 10 Tbps. Just imagine. Okay, in 5G we are talking about 10 Gbps, and you can just imagine in 6G we will be talking about the data rate speed of 10 Tbps, right? And it is 100 times better than the 5G networks. And just see the latency period. The latency period will drastically come down to 0.1 millisecond when compared to 1 millisecond in case of the 5G network, right? So very interesting slide in comparison of the future 6G network, which you can just see the connections. We will be having more than 1 million of connections per network in case of the 6G technology. What is the features of 6G technology? You can just see this is a comparison of 4G, 5G as well as 6G. Peak data rate, you can just see in case of 6G it will be 10 Tbps, and you can just see the data rate, peak data rate of 5G and 4G. You can just compare. Latency, you can just see it will drastically come down to 0.1 millisecond when compared to 5G of 1 millisecond and 10 millisecond in case of 4G. Okay. Connection density, you can just see it was only possible to connect 0.1 million devices per kilometer square. But in case of 6G, you can just see you can have a connection of 10 million devices per kilometer square. Okay. If I talk about the spectral efficiency, you can just see the multiplication factor which has been shown over here. So 5G is 100 times more better than that of 4G, and 6G is 100 times more than better than 5G technology. You can just see the available spectrum, what is available in case of 4G, 5G and 6G, right? So if I talk about the implementation of artificial intelligence in this generation networks, so we had nothing in case of 4G fourth generation. In case of 5G, we are having partial implementation of this artificial intelligence technology. And in case of 6G technology, we will be having complete artificial intelligence getting involved in this 6G communication. Okay. Now, what are the key enabled technologies related to this? So we will be having beamforming. I will tell you what is beamforming. We will be having massive MIMO. We will be having visible light communication. We will be having device-centric architecture. We will be having millimeter wave. We will be having small cells, terahertz wave, and full duplex. Now, millimeter wave, a very interesting thing. So I talk about the 6 gigahertz cellular communication. Okay. So this 6 gigahertz cellular communication is applicable nowadays for medical imaging, microwave remote sensing, amateur radio, terahertz computing, and the radio astronomy. Okay. Now, if I talk about the research area in the coming future, we will be having this bandwidth option of say 30 gigahertz to 300 gigahertz. So this is the future area of research where your wavelength will be varying from say 1 mm to 10 mm. Okay, that's why we call it as a millimeter waves. Okay, and the high frequency waves are used in some satellite applications. These are the few applications which have been shown over here. Another problem with millimeter wave is that it cannot penetrate through buildings, obstacles, and they tend to get absorbed by the ray. So there is a problem of having very shorter wavelength because the wavelength is comparable to the size of the water droplets. So what happens that water droplets itself will absorb this millimeter waves, and hence your communication will be stopped. So you might have noticed that when there is a heavy rain, you get a problem of connection from the satellite to the say your TV connection like Tata Sky and other users. Okay, so there will be no connection. You get a message over there. So that is basically what happens that the rain itself absorbs the transmitting signals from the satellite over there. Now this is the millimeter terahertz wave range, which starts from 3 gigahertz say to around 3 terahertz, and you can just see the terahertz wave ranges from 300 gigahertz to 3 terahertz. And if I talk about the millimeter wave, it starts from 30 gigahertz to 300 gigahertz, whereas microwave band starts from 1 gigahertz to say 30 gigahertz band or 40 gigahertz band. Okay. Now, what are the advantages of terahertz? Their interference-friendly deployment. They can be easily the scalability issue is resolved in this terahertz frequency range. The security will be enhanced, and you will be having very low power of consumption, because this low power consumption is very important factor, because your battery needs not to be drained out so early. And moreover, when you're deploying it in the satellite communication system, it has to be, or when you're deploying this 6G communication system in the base station also, or the battery consumption is very important, right? And it is also again a hot topic on the power consumption nowadays. Then we have small antenna. Naturally, I told you this, the antenna size will become small as we go on to the higher frequency side, and we will be having focus beams. Now, terahertz applications, they are applicable in imaging, spectroscopy, holographic telepresence. Okay, probably you might be knowing this holographic telepresence. Then Industry 4.0 as already I have spoken, and massive scale communications. Now, what are the disadvantages? When any technology has advantages, they have the disadvantages also. So complex circuit design, the circuit becomes very complex. I already told you that there is a high propagation loss. Okay, so this is a very big problem in case of the deployment of 5G as well as 6G communication in coming future. Okay. Now, if I talk about the massive MIMO, what I call about massive MIMO, simply I talked about the 1024 elements deployment, right? And you can just see the figure over here. You have the antennas element array more than 1024. So you can just see what is the importance of this. Now, this array technology can form a beam. So you have multiple beams you can see over here designated by different colors, and they are getting connected to different mobile users over here. Now they are device centric. You can just see we have a main base station. Okay, so you have a backhaul station present over here, which will be transmitting the data to the millimeter wave base station. Okay, and a small cell base station needs to be deployed. So that's what I was saying you that the cost effective will be more, and finally they will be connected to the user terminal. Now, comparison of massive MIMO and MIMO. So you can just see number of antennas. If I have less than or equal to 8, I simply call it as MIMO. And when I call it as a massive, when the radiating elements are more than 16. Okay, so these are the key factors where we call it as a MIMO system and where we call it as a massive MIMO system. So you can just see the different comparisons over here. Okay, so antenna coupling is very low, and the antenna coupling will be very high. This is due to the reasons that the increase in the number of radiating elements. Okay, so that as an antenna engineer, we need to encounter, or we need to take care, and we need to get rid of this coupling factor. Okay, so if I talk about cost, the cost is very low because you have to just deploy the number of radiating elements in the number of 8. And if we go to the massive MIMO technology, the size of the substrate also get increased, and naturally the size of the cost of the antenna will also get increased due to the increase in size of the antenna also. Okay, so the scalability is not possible in MIMO system, but you can have high scalability in massive MIMO system. Link reliability is very low, but in case of massive MIMO, you will be having a very good link stability. Okay. Now, at this point of time, I finished my first part of my talk, and if organizers permit me, I can start the second part, or if you want, we can have a break. I leave it to the organizers.
Much for your presentation. And now I request you take the break for 10 minutes for all the participants. So after the break, we will start the session, sir.
Okay, sir. Sure.
Thank you.